All right. Um, okay. So, recently I've come back to a project I started a week ago. Not a week, a year. Ooh, been working on it more for about a week. Yeah, a year ago. Um, it's a game engine. Um, yeah, I mean for it I've never really made one of those. I don't really feel too comfortable hopping in head first into that. So I've kind of been following this tutorial um for that. So during the stream I'll just have this, well, it's a playlist. But yeah. Um yeah, the Cherno um kind of ties into my title, the engine churns, right? Stream title. Yeah. It's a good little pun. Um all right. I don't know if I can hold on. I might have to mute the music for me. Just turn it down a bit more.
Overwhelmed with stuff like this, think about what it
Picked
actually
up
is.
with
As I've mentioned before, it is a bunch of
materials.
code, which is our shaders, right? We have a vertex shader and a fragment shader. The moment we're storing that in a shader, in a Hazel shader object, which is fantastic. That's all we need. And then we have a bunch of data. So we're not actually using
Wow.
uniforms at all
I'm
at the
not
moment.
copying this
Throw me
one to
out
one,
for
by the
our
way.
vertex
I'm
shader for
because clearly I have
for our
a
transform,
kind of
for our
different
projection
goal.
matrix, and that's
I'm
all
pretty sure
fine.
this at
But
least it
we've never
started
actually
out
used
kind of
uniforms, I
just as
think,
a tutorial thing.
in the fragment shader.
Um,
So
I'm
first of
just
all,
trying to
let's
make
just take a
something
look at
that's
what our end goal
highly
is. I want to
modifiable
make
and
these.
that
Let's just
can
say I
make
want to make.
modify
Maybe I'll
highly
make two
modifiable
different types
games. That's
of
kind of the goal.
squares. So you saw we had a grid of squares. That's great. I want one of them to be blue, one of them to be
Um,
red, right? So what I'll do is
oh my god, what
um,
are you doing?
so
I
maybe
haven't been
we should
looking.
make half of them blue, half of them red. I'm not sure. But basically, what I'll do is the first thing I'll do is just find the red. So we'll have the red color, which will just essentially be a color, right? Now
Wow,
let's take our blue
red.
color because I want to make the red color the same kind of shade. So we'll make red color and a blue color, and they'll be
This
vectors.
is kind of awful.
Let's just do this quickly. And then this will be the blue color.
Oh yeah, and the name for this thing is
Will
kind of
be
just
that's the blue color, and the
horrible.
red color will be just point 0.8,
Um,
0.2, 0.3. Okay, so we've got two different colors.
hold on,
I
let
want
me
to
pull up
make
the GitHub.
we can just literally alternate this. So what I can do is I can say essentially that if I, mod 2 equals 0, right?
Yeah,
So this is
that.
just basically
It's
that's what
like
this
an
one represents.
acronym and a
So
backronym,
where
or
kind of
well,
as we go
backronym
through
and
the
then
rows,
acronym
every
smushed together.
second one will be equal to
And
0,
it's
right? So 0 will
ooh,
be 0, 1 will be not 0, 2
um,
will be 0, etc.
but
What I want to do
whatever,
for that is
you know.
actually set this shader, this
Not
blue shader
everything
is
needs a good
uniform,
name.
which I don't think we have a uniform mat for. We'll do upload uniform float for. We'll set this to be the red color, and then otherwise we'll set it to be the blue color, right? So we kind of have an alternating pattern now.
Wait,
Now,
I like
obviously,
this
this is
song.
not efficient at all because usually you would like to batch together your materials. So in other words, you would like to do as few of these as possible. So what I would actually do is render all of the red squares
Hold on,
first and
what
then
is
all of the
he?
blue squares. Just want everyone to understand this is just a test and we're not talking about efficiency or the optimal way of doing things.
Um, so yeah, I guess you wanna. Okay.
But we basically do this and we end up with an alternating pattern of colors. So let's visit our shader class and make sure
Yeah,
that
the
we have the right
way I
function.
handle
So
rendering things is kind of totally different from what he's doing.
we'll have upload uniform
Um,
float for. This really needs some
he
work,
has
by the way,
some
the shader
weird
class. So maybe
renderer
that's something that
command
I'll do
thing, and I'm like, no, just
next.
make a rendered
Because,
subclass and then
yeah, I mean,
have it
there's a
directly
lot of
built
stuff
into
that needs
that.
to be done here. We'll
But
have
you know,
values, I
whatever.
guess. this. Come over here.
He definitely does things a bit more object
Paste this in
oriented.
here. We'll get the location as usual. Um, I saw someone leave a comment about
And
caching the
I built
location.
like a
Yes, that
completely
can be
different
done.
event system,
That's not a bad way of just. That's a quick,
and I
dirty
did
way of
my
just
own
saving some
math
performance. Usually,
library
usually you'd
code.
calculate all locations ahead of
I
time,
mean,
but
I ended
I
up
have a
adding
shader anyway.
GLM as well,
So that's
but
not
yeah,
something that we're really gonna. What is it? Float for uniform vec. What is the function? I can't believe I don't remember this. Oh, it's just 4v, 4fv. No, 4f.
can't believe he
Okay,
doesn't
there we go.
remember.
Um, Doing this from memory, of course.
Come on.
And then we have the location, and then values x,
Ugh.
y, z, and w. Yeah, usually you would basically just have a system that reads the shader, parses the shader, gets all the uniform values from that, and then actually like gets the locations of all of those uniforms. Just
Okay. Yeah. Um. Oh my god.
right there and then. And then you do that when compiling your shader. That's it. That's done. They're saved because the shader is never going to change, right? If it does change, then you obviously recompile it. And then that way you also get other bonus things from that, like validation, making sure the shaders actually exist. Making like since you're aware of the shaders and their types, you know how big your buffer needs to be so that you can store all of them in a buffer. And that kind of just goes down that road. So we'll end up doing that in the future. So I'll call this my u underscore color. That's going to be the name of this uniform. Okay. And I'll just make this inside the blue shader, right? So the blue shader is now going to be a flat color shader.
Hmm.
And I will actually go as far as to rename it flat color, just so that
Yeah, I
there's no
figured while I'm
confusion as
watching
to what it
this,
actually is.
I'm not really gonna be doing much
Make a
coding.
blue shader as well.
So if anyone shows up, this would be like, prime time to
Okay,
talk about stuff.
so how do we add a uniform? Simple, we just type in the word uniform, and then the type vec4, and then the name of the uniform
Wow.
u underscore color. And now what I'm going to do is output color to be u color. Pretty
Wow.
simple. Could have made this a vec3 and just kept the alpha constant nodes 1 as well. That's fine. But we'll do that. Maybe you guys can try the other way at home. Let's hit F5 and we should get some kind of difference in our squares now. Some of them, half of them essentially should be blue, half of them should be red. Okay, and there you go. So
Wow.
you can see half of them are red and half of them are blue.
Run this and show what it looks like. Hopefully the uh, gnomes didn't run all in and break everything. Hopefully this works. You know, I get a lot of warnings, but they're warnings. So WASD to move the camera, and then the arrow keys, specifically the numpad arrow keys, because my actual arrow keys don't work except for down, and I didn't feel like checking for both. To move the triangle, so you can see. I don't know why that should be about the same speed. It's kind of weird there. Um, oh yeah, and the output that's just it's running at like 1200 frames per second, or is it 12,000? I think it's 12,000. If we actually stop this, um, how? Yeah, like 1,000 frames per second. Yeah, it's really good. But yeah, I got a nice green square. and this primarily colored triangle. It's really nice. I don't know why his looks so faded, but that's whatever. And then when you click the close button, it does all that, and it's all very nice. Um, his events that he has kind of resemble, at least the way he does it, kind of resembles Unity a bit more. And then I actually took inspiration for the event system a bit from JavaScript. You know, you still have like different like layers, like he has, but instead of like, I kind of forget how he actually made his, but mine is you have different layers. You have the app layer, you have the window layer, you have the UI layer, and then I need some water. Jesus. On those different layers, different types of events are raised, and like in JavaScript, they'll bubble up the layers, kind of like they bubble up like elements on the page, and then once it either gets to the top, or bubbling is canceled by like whatever event handler, then it'll start going back down the layers, and then it'll go until it reaches the bottom, or until it's called capturing for some reason, going down, uh, or until capturing is canceled. So yeah,
That's perfect. So we've basically introduced him.
my music lose its shit. What? How'd that happen? What? That's not good. I'm just gonna assume that's odd behavior and run it again, and then hopefully won't have that issue. That does mean I need to restart overlay and stuff. Okay, let's hope that doesn't happen again. So otherwise, I might need to take a bit of a detour. Um,
Material, haven't we? We've got a shader that is somewhat flexible. We can add any color we want. We can easily just add an
wow,
IM GUI
any
control
color.
to actually
I
change
guess
that.
I
In
could
fact,
do
that
that.
might be
It's
something you
really
guys can
like
do for homework. Just
nothing.
add an IM GUI control so that you can actually play around with the color, and we can do that next time as well. Um, but essentially, what we end up with is a way to actually pick any color we want and set it into the shader, and
Instead of
then
V
render
color,
something, and it will be with that actual value, with that red value or with that blue
right? This
value,
would
which
be
is pretty cool.
uniform.
Um, that's all great, but we never want to do this like this way, essentially, right? Where we actually kind of take the shader and then we upload a uniform float 4 to it. That's weird. We instead, what we want to do is define some sort of material, more or less in an API that probably looks like this, where we have kind of Hazel, and I can show you kind of what a like an end goal API
Blah
might
blah
look like,
blah blah
because we're
blah
definitely not
blah.
going to make that today. But if I make a material, essentially, usually I take a material, probably have some kind of material ref, because we'll introduce some using kind of raw pointers, or kind of data, right? Is like typically what this would do is actually take that shader, get all of the information about what data that shader needs. So in other words, the uniforms, specifically the uniforms that are applicable um, to actual like materials, right? So for example, right, yes, we could take all of the uniforms, which would be three. It would be these two in the vertex shader and this one in the fragment shader. Not good though, because a view projection matrix, that is not, how is that part of a material? It's not at all. Neither is a transform matrix. So maybe we should
It
take all the
could
ones in the
be if you
fragment
were
shader.
if it
In
was
this
a
case, it
really
wouldn't
cool
work.
material,
But what if we have
but
like, I don't know,
you know,
a uniform vec3, light direction? That's a bit weird, isn't it? I mean, why is a light direction part of a material? I say this all the time, but when you're designing things, make sure they make sense, right? This bunny here, which I've basically committed to picking up the for every episode in this series. This bunny here, this is what's the material of this? Does it have anything to do with where the light
it's
is
bunny
coming from?
material.
Right there, by the way. No, it doesn't. It's just, yeah, sure, the light hits it, it reacts a particular way to the light. Why? Because it's got a material, right? It's got some kind of form, it's got a surface property that defines, like, it's all like kind of furry here and actually feels quite nice. But anyway, it
Okay.
it has all of that. It's got a material. Use a whiteboard or a
Uh,
piece of paper if you need to. Jot everything down. Ask yourself or ask someone else, does this make sense to you? Should the material for the bunny contain the light direction? The answer is no. So because of that, it's again, you can't just take all the uniforms and be like, that's it, that's what belongs there. No, you need some kind of way to decide which uniforms should be set by maybe the renderer. So like the renderer should set the light
Okay, that's
direction,
just
should
all he
set the
was
view
trying to
projection,
say. I was kind
and
of
should set the
confused on where
transform.
he was
Transform is
going
kind
with
of
that.
per object, even though view projection is per scene,
Um,
and so is light
yeah,
direction.
I
Um,
kind of just
but
already
we
assumed
also
that.
have another group of uniforms, which
Like,
is
duh.
to do with specifically the
All
material.
right,
So we need to
whatever.
take those uniforms, and we need to basically create enough storage, like a kind of backing buffer that actually stores all the data that we need. And that's typically what would happen upon constructing a material. Once we have that storage, we'll be able to do things like material, material, maybe just set,
Like, should you reuse
and what are we
the for
setting? We want
layout
to
for
set the
that or
color of the
what?
material, right? To be, red color. And that's
Wow.
it. Now, there's also the concept of materials and material instances, which are material instances are essentially just an instance of the material because you might want to define a base material. For example, this, I don't, you know what I mean? Like instead of making a red color, because this now becomes a red color material, doesn't it? I mean, it's like I've set the material's color to red, right? And then maybe I'll apply it to my mesh. So I had like a square mesh. Let's just say I had like a square mesh, right? And then I kind of just say, set material or whatever, to, let's just say, material, right?
Okay.
Material that is unique um, might be I have a kind of physically based rendering metal material that's map, might have a few kind of particular things that makes it unique because obviously you wouldn't often render a scene filled with everything that is exactly in the same shape. It might be the same material, it might be a lot of wood in your scene, right? But it it's likely that it's different types of wood or it's different like qualities, like it might be a bit degraded
Mm,
or whatever. So we kind
one
of
thing I'm kind of
end up with an
bothered
API
by
that
with
someone looks like
my
this, and this is something that
shader
I've actually
stuff
done in the private branch that's available to patrons, by the way. Huge thank
is
you to all the patrons who make this series possible. Patreon.com/the cherno. Yeah, this stuff has already been done there, so I've
um
kind of tested this code, and
the
if you want to see it
ID,
right now, you can
right?
just help support the series and you'll
I
get
kind of want to be
access
able
to
to
all
be
this
like,
lovely code.
hey,
Anyway, back to
same
this. So
ID,
I
different
kind of have done this already, but
object,
essentially you
you
might
know?
have like a material instance ref, which would be like your actual material
I don't
instance.
know if that's
This would
smart.
just be
I'll think about
the
it.
same kind of thing where we have a hazel material instance is made from a material, and then we can set certain like colors. In this instead,
Blah blah
if I just kind of
blah.
get rid of this code for now, we would instead go ahead and maybe submit something. We wouldn't use a shader anymore. We'd submit something with a particular material, and then what that material would do
Just while
is
he's
upon us
talking, I might
binding
as
that
well
material
go
inside
over
renderer submit, it wouldn't like the
the
renderer does
math
this stuff. That's fine, but
library
ultimately
system I have.
we
Sorry,
bind the
up
shader, and
here.
that's fine. That's all needed. That's all necessary.
This
And then the
if
next
this
step
name
for
gets
us would be to
defined,
actually
you know,
take that material
for
instance
the
and
build
bind it.
system,
And by
there's
doing that, what that does is it binds the shader and
premic.
sets all of the values
I don't
that
feel like opening that
um,
up. Actually, I could
sets all
put
of the
up here.
data that we've actually are storing inside material instance. And that's just
Yeah,
fantastic.
premic.
That whole kind of
So we
system.
have premic, and then
It's
you
great.
can
You can
define
really
different names.
extend
So
it,
like
make
you
it
could
really
specify like
powerful. I might even like I don't wasn't planning on doing this, but I could show
right. So you could
maybe
do it
next
there,
time
or like
this stuff
however you
kind of
want to do
working.
it.
I'm not sure. Sometimes I'm not sure what the
Um,
best way to explain some of these things are. And I definitely want to kind of do this in more of like
It
a
was like,
formal way
oh
with
yeah,
like,
if you
drawing
define
diagrams and
this,
stuff. I
then
think
it's
that's
like,
kind of
okay, I'll use
important.
GLM,
As we get
which is
into more
just
complex
a
topics in the end,
math
and sometimes it's good to
library
have an
that's kind of made
example, and
for
I've tried to
OpenGL.
kind of do that for you with somewhat pseudocode,
Otherwise,
but
you
also
use
code that looks very
the
similar
kind of
to the
more like
final
built-in
API
one that I
that we're
wrote
kind of
myself.
working towards. But
I had to look up
ultimately,
linear algebra for that.
you
It
have
was
kind of
really
different,
great.
like, so I might show you some of the
Um,
development branch stuff
that's
because,
actually what
material
kind of
instances,
made
materials,
me take
all that
a
stuff is kind
year-long
of
break
vital
from
to
it
get that to
because
work
like I
properly.
just wanted
Um,
to move
and
on,
quickly as well, because
and
again,
I
unless you
had
have a bunch
to
of
sit
objects that
down and
render with
I'll
different
show what I
materials,
did.
you end up
Um,
kind of being able to batch them together, so that you kind of do some render
oh, that's
sorting
transform.
essentially, so
Where's
that you get all
matrix?
of like the red squares, as I said,
Yeah, here.
here, and then
So
all of the why, because
you
the
see
red
it's a two
squares
by
have the
two
red
matrix, and
material
that's not
instance.
too bad.
So let's, when we
Then you go
submit
down
everything
to
to the
three
render
by three, and
to the
it's like,
renderer,
oh,
since we don't
okay,
render everything at
that
once,
looks pretty
hypothetically in a
crazy.
good renderer, we have all
And
that
then
data, and then when it comes time to sort it, we can say, okay, well, everything that's red will render first, everything that's blue will render second. That way, we only bind two materials, right? We bind the red material, render everything with it, bind the blue material, render everything with it. Obviously,
okay,
certain shader properties like the
yeah,
transform still needs
he
to
did.
be set, that's fine, but at least we're not setting the color every time we want to render one of these squares, because we are rendering 400 squares. If we do 400 material flips, that's going to take way longer than doing less.
Okay, so
Anyway, I think that's probably about it in terms of what I wanted to show you guys.
doesn't make mm, if he okay, so you bind one, set the color, bind another, set the um color, right? And then you go through each square and set the transforms, but I mean the way that currently is now, you just have to I guess the way it is now they're kind of connected, but maybe he's describing a system where the color shader kind of is separate from the one that has the transform in some way. I don't know. That sounds weird right now. That's fine.
If we just jump back here for a sec, though, textures work the same way, right? I mean, you could make like a set texture. You don't necessarily have to. We haven't dealt with textures yet.
Oh
That's something
yeah.
that we really need to
But
do.
yeah.
But if we had a texture or something like that, like we might have texture, we
Yeah.
might have like an albedo map or
That was
something.
miserable.
We
And
can just
don't
set
get me
that
started
basically
on
by just
inverting
uploading a texture
these
reference or
fucking
something like that.
things.
In kind of the same
Um,
way, or you could be a bit,
Holy
you could almost
moly,
twist it so that you know
that
what you're actually
was
doing, and you
so
can
much work.
like set texture, and maybe you have set texture, set
Actually
value. You can
took me
design this
like
API
two and a half
however you like,
hours.
but
Um,
essentially, like, it works the
After
same way
I
with
looked at
textures,
a
and the
YouTube
material
short.
or the material instance would store a whole bunch of
Um,
link references essentially.
yeah, it was funny. So yeah, first you need to, calculate the determinant, and then from there you do a bunch of awful math. Um, I'm doing it like this just so it's, um, in my mind that's like more efficient, and really it is. I compared it to the GLM, and I'm only like, what was it? That was in nanoseconds. It was like I was only like a few microseconds like behind on average. I sometimes faster and sometimes slower. Um, but it's those things kind of fluctuate. But yeah, for writing it myself, like a few, um, I mean, obviously what I wrote isn't nearly like as flexible as GLM, but like it was something. Um, and then there's also the transforms, and that's like a lot of math. Um, hmm. I mean, one thing I will say is that when it comes to, I feel like mine is a bit more flexible with this specifically with the rotation. Because I recently had to deal with something where um was it in here? Yeah. I have to check if it actually has rotation, because and this is kind of like a merged this code will work with either GLM or the math code I wrote, because I made it work that way. See, doing the if def again. Use this, otherwise use these that kind of try to match up the signature um with what it is in GLM, so that I can just call these and it works. Um, but it was working fine to just like chain these together without really caring with my math code. But specifically with rotate, if the rotation was zero, if there was no rotation at all, then it would fill the transformation matrix with a bunch of nans, not a number, and that kind of just ends up with nothing showing up on screen, and it's like, oh, something went wrong. But I don't like that. I don't want to change it now. I don't know if I want to use shared pointers. I might. I also don't want to jump into that, because it's not like they're really free. Um, I mean, it's literally just a counter, and I also kind of just hate the It's whatever. I just want to
Essentially two textures, and then we could basically render something with a particular texture.
think of
So
the big thing. I have
it's a
to
really
think
nice
a lot.
system. I really like the whole
Can't just
materials, the concept
jump
of
in and
material
code
systems.
stuff.
I've always kind of liked it because it just it's amazing how much safety it actually gives you. It's almost like smart pointers in a way. Like you could just
Ooh,
upload
yeah.
uniforms, like
Smart pointers,
if you
that's
look
the
at kind of
name. I
people learning OpenGL for
kind
the
of hate
first time or
those.
graphics programming for the first time, what are they doing? Usually they create a shader. They'll be probably smart enough to create like a shader class or something like that, and then an API that lets them set variables and set uniforms, and they can make something essentially that ends up validating that, making sure stuff exists. Maybe if location equals -1, which means the uniform couldn't be found, they log that or they assert there so that they can debug it. That's all great. But having a material system where you can actually, like a proper one, where you can ask the shader, hey, give me all of your uniforms. Okay, it occupies this much space. Okay, I can store them in a buffer and then upload them when needed, or I can like have a material instance which overrides that buffer and says, this and that or whatever. Um, it's just amazing because
Let
nothing
me
will
double
ever kind of go
check.
wrong with this if you write it properly, and that's kind of what we want to do,
Um,
obviously. So yeah, super excited for that. We
oh yeah,
need to, before we can
predefined
actually
file
do this though, we really
is
do need to
literally
build up
just
our shader
so
class a little bit more. I mean, we
there's no
can't even reach
circular
faithful files at the
includes
moment.
or
Um,
whatever.
so that's kind of definitely something that I want to do. The
Or
other
like I don't
huge
have to worry
question that
about
I
the
have for you
order
guys,
which
and I
I
have asked
define
that, and I'm
things
going to
in
ask it
in the actual
formally
header
right now, so
files.
listen up. Do we want to proceed with making Hazel a full 3D renderer right
He
now,
does
or
2D
do we want to
first.
focus
I know
more
because I
2D?
looked ahead.
Um, Again, materials less so useful for 2D because usually you would render pretty much everything in a 2D scene aside from like special effects or special things with just a
Has its
single
own
shader, so you don't
image.
really need too many materials. You can just have a 2D renderer which basically renders colors or textures and shapes. That's all you need. Um, so it would kind of put this stuff on the back burner, which is fine. We still, either way, we still need to revisit our shader class, and we still need to 100% revisit textures. So I'll probably do one of those episodes next. But the real question is, and I'm
You'll
going to make
never
a
guess
poll.
which one he does next.
Last time I made a poll. I didn't really like it too much because I
Okay,
don't
this
know how
this
to see the
is
results. Hey, what's up, guys? My name is Cherno. We have very little actual functionality to do with shaders. If you were to sit down and actually write a shader class in Hazel right now, you would spend a week on it probably because you need to write a lot of other systems. You need to tie it in with material systems because in the big scope of things, if you open up like Unreal Engine's source code and you take a look at how they handle shaders and how they integrate that with materials and how all of that works, it's immensely complex. It's not just like it's not like 1,000 lines of code that you can just jam in and everything works. It's a whole architecture, it's a whole system. And since Hazel is all about me kind of showing
Whole
you how everything works step by
um
step, and not only showing all the code that I'm
system.
typing on screen, but
I
also
forgot what he's
making
talking
sure that
about.
I'm kind of
Okay.
iteratively working on Hazel,
Texture,
meaning that, what we
you
have
know,
right here,
ooh,
right? If we just like take a look for
I'm a
one
bit
second,
tired,
what we have
but
right
it's
here
fine.
with like a triangle and then all of these quads
Today is a
being
good
rendered,
day.
like with every kind of column being a different color, red or blue, um, that kind of stuff,
What? Is that a
we could
gun?
spend three
Holy
years
moly.
rewriting this code, refactoring it to do this, because you could do this in like 200 lines maybe of just OpenGL code in one file and you'd be done, right? Or you could do this in Unreal Engine or like Frostbite or something like that, right? It you could write it however you like. It's so complex. So I just want to get that into your heads that um, doing something like this from the get-go and immediately writing this amazing engine with an amazing material system, an amazing shader system, that is not something that we can actually physically do. If we were to do it, again, it would take 100 videos, and everyone will probably lose interest in this series because we've been making
Hey
little
man,
squares for
I'd
100
stick
videos.
with it.
So I'm just kind of trying to structure it in a way that is both interesting to you guys, but also shows kind of almost
He
like,
actually
a
did put out
basic
a
engine all the way up to
video
like
for
something kind
this
of industry
recently,
standard,
like,
something like
hey, I'm
AAA.
gonna
So
start
that's the
this up
goal of this
again.
series. Just
Or
to get that into your heads.
not start
Anyway,
it up, but
patreon.com/slash
like
best way to support
continue
this
doing
series.
videos with
If this stuff
this.
is a little bit boring for you and you want to see like some physically based rendering or some like an actual kind of proper like model viewer which has
Oh
a
yeah, he
real
did
3D
like
renderer with like a camera and
some
everything
like
integrated
GUI thing,
into
and
it,
I kind
then
of
check
saw
out
that and I
patreon.com
was
slash
like,
Paterno. If you do help support the
no,
series, you'll get
I'd
access
rather
to
do
source
that
code where I've already
myself.
achieved all of that, and that'll kind of help accelerate
So
your
I'll get to
learning a
that
little bit.
when that
And that is also
happens,
what we're
and
working
that will
towards
be
with this series.
probably
So
the
today, what are we
most
going to do?
fun and most
Well,
miserable thing I've ever
step one
done.
is going to be to refactor the shader class very slightly, just to get it out of the idea of being OpenGL only. Because right now, if you look at shader.h, shader.cpp, it has OpenGL code in it. It's tied to OpenGL. We want to get rid
Ooh,
of that association. Second of all, we want
um,
to add more
you
uniform
see,
functions. So at the moment, we can only, I think we
not a
have a mat
single
4 that
line
we can
of
upload and a float 4 because
OpenGL,
that's what we use for
nothing.
this color.
Um,
We're
Now
going to make it so
you
that
can
we have all of
ignore
the uniforms that we actually
like
need to
GLFW
upload.
shader, because
And then third of
that
all, I actually
uses
want to add some kind of
that.
color picker to our
Hold
IMGUI
on.
UI, like I said last time, so that you can actually pick the color
Well,
of all of these squares.
yeah,
Just for simplicity, we'll probably make all the squares the same
I
color, but you'll
actually
be able
thought
to
he
actually use a color picker
abstracted that
in the
pretty
engine
well
to
by
pick
now.
what
I
color you
didn't
want
know
the
that.
squares to be. So
He
that'll kind
still
of just show
needed
dynamic
to work on
uniforms
that.
being up, like I said last time,
Listening.
so that you can actually pick the color of all of them. On the
Okay.
topic of uniforms, I don't want to talk about uniforms too much. As I mentioned last time, uniforms are something that a proper uniform system needs a proper material system, because typically what you would be doing is basically using the material API. When you bind a material, when the renderer actually binds a material, you would typically just take all of the uniform values that you need from both the renderer and from the actual material that you're using, and then upload them as kind of one buffer, one contiguous buffer right into the shader, right? Because you want to transmit all of that data to the GPU kind of in one batch. That is not what we're doing right now. That requires a
Okay.
little bit of setup. We need a proper renderer, we need a proper material system, all that kind of stuff, and that's coming in the future very soon. You guys seem to have voted for 3D, and we'll have another poll
What?
as well just to make it more formal, because the YouTube, honestly, the polls on the YouTube videos I really hate. Like, they just give you
Man,
no the content dynamically. Okay, so
5 years
first thing we're
of
going to do is take a look at that shader class. So as I mentioned, if we go to our shader class, this is shader.cpp. If we look at where it's located, this shader.cpp thing, if
really
I go to
feel like
Hazel,
listening to this
whoops,
song again.
and show all files is what I wanted to do, and we just quickly take a look
Ooh,
at where it
good
is, you
song.
can see that
Up
it's right
next.
here. It's in Hazel renderer shader. What is this? This is a API independent and API agnostic API, an API agnostic API, a render API agnostic Hazel API, right? Hard to say and doesn't really make
Oh,
sense, but the point is all of this code should be completely generic. You can see
agnostic.
that in the case of our vertex array, in the case of both
Why
index
is
buffers
there
and
an
vertex buffers,
error?
we do a switch to determine which API we use. Whereas Shader does none of that. Shader just has pure GL code in it. It has no switching. It's just a full class. That's not what we want. That's not what we want at all. So the first step is going to be to go into platform and to go into
I guess I
OpenGL,
could
and then I want to add
upload
a new file, two new files.
uniform float 4.
One's going to be called OpenGL shader.h, Okay, and then I'll also make a OpenGL shader .cpp file. And then what I want to do is the CPP file, we're basically just gonna, let's go to the shader file. Let's open up our shader class, and I'm just gonna copy everything because it's basically what we've written here is an OpenGL specific shader class. And I'll do the same for the CPP file. I'm just gonna copy it straight up and paste it into here. All right, that's much better. So
Wait,
now what we'll do is
wait. I I did the thing he was going to do, but like several episodes like before he did it. Ooh.
make it
Uh,
specifically an OpenGL shader class, like we did with vertex array, with vertex buffer, all of that stuff. We don't need to include this stuff, but we do need to make sure
but I do
that we
still need
include
to.
Hazel, renderer, and shader.h. Okay.
Why are
This
you
obviously becomes
angry?
OpenGL
Oh,
shader.
'cause
The constructor will also be virtual.
needs to do that.
Bind and unbind will end up being kind of virtual const overrides like that. And then this stuff we're going to keep in this class because we don't want to expose this kind of API to the shader. Now, this
Suppose
is
everything everywhere,
this
man.
involves a little bit of discussion, so we'll probably just
I guess. I
talk
don't know.
about it as we go. But essentially, and we'll do the same thing that we do for
It's
all
not a
of
mat
our
four,
like
it's
every
a
other classes. So if you take a look at
Vic
like
4.
buffer or
I'll
something
do
.h,
D.
you'll see um,
Yeah,
that we
the
also
other thing,
have
when I first started
we have
like
like a virtual
making this,
constructor.
I
We've
had
got
like almost never used
bind
C++.
unbind, and we've actually done this as
So
default here, which
that
I
was
guess we
like
can do
really cool.
for here as well, just
Now
like
I've
this.
used it
But
more.
you can see that we've got
Um, so coming
we've
back to
just
this
got
was
like
really funny
we've got
because
our
like
like
it
a
was
virtual
like,
constructor and a bunch
wow,
of
I
virtual
wrote that
functions that are
really
pure virtual
stupid,
and no data
and
members
I
in
had to
here, and then
redo
like a
it.
static create function. So that's exactly the pattern that we're going to be following for our shader class.
That's
So
silly me. Those aren't
this will just be
matrices.
pure virtual.
Let's call it
This
Vic.
disappears because we don't want to expose it. What we will in fact have, and this is already done in the Hazel development branch, what we will actually have is just like a virtual void, upload uniform buffer, right? But this will be a little bit more complicated because it will be different for like vertex shaders. It will be different for like material uniforms versus renderer uniforms because they might get uploaded at different frequencies. Therefore, they might be like actual different buffers inside the GPU. There's a whole lot of actual stuff that needs to get written for that to happen, but that's just a little bit of a peek into the future if you're wondering how on earth this system works. Now, you'll note that we do not expose anything into this shader class.
I can't use any
Um,
fancy like
we don't have our upload
XYZ
uniform mat4 or float4 exposed at
because
all. So how do we
that
currently
won't
with this
work
system
across
upload uniforms?
both
You may be asking
math
yourself. So the
libraries.
answer to that, as
I
you'll
do have to
see, is
write
we're
my
just going
code
to
like
enter,
that, and
whilst
it's
we will create a
not
shader,
the
it'll be a
worst thing
shader
ever.
pointer. What we will actually do is
Why are you mad?
basically cast
Oh,
that shader
location.
to an OpenGL shader because clearly it's going to be an OpenGL shader object at this point because that's the only
What
render
are you
API we
talking about?
support.
I wasn't paying
And then by
attention.
the time we start supporting other render APIs, we'll actually have that material system in place, so we'll never have to cast. So if that makes sense. That's kind of a way for
Okay.
us to skip ahead, but also be able to retain that functionality without writing a whole bunch of code that we'll never ever need. That's it. That is our whole shader class. Now we need a static shader pointer create function. Now, what do we have inside our OpenGL shader? We had a constructor which takes in a vertex source and a fragment source. So that's exactly what
Create vertex.
we'll paste into create. I'm going to open up vertex array.cpp and steal basically all the code in there, and that's going to replace the code inside shader.cpp. Obviously, we'll include shader.h, and
Let's copy
renderer will
this.
also need to include for render API,
Paste
and then we'll instead of this, we'll include OpenGL shader inside the platform.
F.
All right, so that is looking pretty good.
Why are
Obviously,
you
we replace this
freaking
with
out?
OpenGL shader, and we fill in the nums so that this
Oh,
becomes a create function, which takes a shader, which is in the shader namespace, and then we have that's all correct. Vertex source and fragment source ends up here. Um, that looks pretty good to me. So it doesn't seem very happy because I've got a semicolon at the end. If we try and just Control F7 that to
there we go.
compile this file, see if that works. It does, great. Okay, so that's that's basically the change that we made. So right now, obviously, we'll be creating
And
an
yup,
OpenGL
that's the
shader pointer
change.
every time we do this. Everywhere in the code right now, they should basically be some
Oh,
kind.
he's doing this. He's doing shit like this. Get API. I mm, uh, I'd rather just that be at like compile time and then some sort of using or like macro or something is like defined and does that. I don't want there to have to be a layer of function calls to resolve that when it should already be known ahead of time. But whatever.
Kind of form of reference counted object. So in other words, in our case, without writing our own, that would be a shared pointer. I'm really keen to move over into that system. We might even do that next episode because, as I mentioned, I am getting a little bit annoyed with this. And the more of this we write, the more we'll have to replace later. You'll see how we do that when
You'll
we do
never
cover
guess
that
what he does
because,
next
and again, it's
episode.
stuff that's done obviously in Hazel Dev already, but maybe that's worth doing next time. So potentially that will be the next episode. In fact, I think I will because it's just kind of like this almost boilerplate code that just needs to be written and then we can just forget about it. It's kind of like the core Hazel library stuff that needs to be written, the core stuff. Okay, fantastic. So that's it. That is 100% the end of this class. This renderer ID obviously gets removed because this shader class should have no data, and we don't really need GLM here at all. Nor do we need string. Okay, cool. So I think GL shader already has that, to be honest, which I can't search for annoyingly. Okay, so we just have shader, so we do need
Probably do
GLM
some
just because we have
static
this
whatever
stuff
in
over here.
shader.
So that is looking pretty
Um,
good. Obviously, we need to do some find replace stuff here. So open GL shader. I'll quickly just replace shader
that
colon colon
mimics the
with open GL
I don't know.
shader colon colon inside this document, and then patch up these two things, the constructor and the destructor. All right. That I think is about it for what we need to do
Yep,
here.
that's about it.
That if I compile Hazel, especially if I compile Hazel, but we shouldn't even need to compile Hazel for this to happen. If we take a look at where we've written our shaders
Oh,
instead
his
of popping
output
up,
is on the
you'll
side.
see
That's
that we can't
lovely.
actually create Hazel in the same way. And one last thing that I'll do actually is, that's fine, it's in the renderer. We'll deal with that in a minute. So inside sandbox app.cpp, you can see that we can't actually create a Hazel shader anymore because we can't go new shader, just like we can't go new vertex array because
Mm,
it's an abstract class. So we'll have to do Hazel shader create, just like
Oh yeah, I probably
just like we
have
have to do with
create
all of
like
our other
that,
kind of
but
renderer
instead of doing a
resources.
switch, it'd just be
Um,
an if def, I guess.
okay, there we go. So we create that instead of newing it. And then we have a fantastic problem that we have to deal with. So, and the same thing, by the way, is inside the renderer class when we try to upload these
Yeah,
uniforms.
if def.
Shader is
Cause
currently
like you might as
a
well just
shared
if
pointer
def it, right?
that is
You
of
already
shader of
know
type shader. What we need to do is
with like
actually cast it into an OpenGL shader.
defines,
Now we know it's an OpenGL shader because that's the only thing it could possibly be. And by the time it could be like a DirectX shader or a Vulkan shader, we will have far like rewritten the system, gotten rid of it, and made it actually abstract. But since we haven't right now, we basically have to cast this. So to do that using, you know, proper C++, I guess, we'll have to do either a static cast or a dynamic cast. Technically speaking, we could easily do a static cast because we know what it is. We don't need to do any kind of validation
yeah,
to
I
make sure
added
it's
the
that.
sun.
But just for the sake of being like, nice, I guess, we'll do a dynamic pointer cast into
Can't you
OpenGL
just do
shader
the
like that.
parenthesis thing?
So
What
std
the fuck
dynamic
is
pointer
that?
cast, and then the type we
Is
want to
that
cast
just
into.
supposed
So
to
we'll
be
have to
like
include obviously
tell it what to do a bit better for like
platform OpenGL
optimizations?
and OpenGL shader for that to work. and I'll just copy this and paste it into here. Okay, so now what we're doing,
Okay. Like, what is the point of these? Oh, shared pointer stuff. Okay. Creating problems and
in the future we can easily
solutions
just
for those
search for,
problems.
you know, STD dynamic pointer caster and gel shader. Just search for basically this string and then replace that all with just, you know, not casting it at all because we won't need it anymore. Even though that doesn't make sense because we'll have to remove this function anyway because upload uniform mat4 is not an abstract function, it's a gel shader only function. Great, so that's what we end up with, and we have to do the same thing in Sandbox app. In this case, we're going to change the way the system works though, so it'll be a little idea I found may have worked before and did work before is
I
just
can
because I
hold
think is
space.
that the only shader we have? I'm actually quite surprised that worked, to be honest, because the shader was never
Now
bound
he's so
when we used
silly. He's
the shader, but
talking
let's
so
bind the shader. So
fast.
we'll do flat color shader bind, and again we'll have to just copy that. We'll do a few things. We'll have to copy this include from the renderer into the top of Sandbox like that. And then we'll have to, since that's actually part of Hazel, I might put it first, like that. And then we'll have to do Hazel,
Blah
gel
blah
shader,
blah.
right type. There we go, bind. And then what we'll do is we'll actually upload. So red color, blue color, that's all great. What I'll do is I'll actually create a member here because we're going to tie this in with IMGUI, as I mentioned. So this will be a GLM vec3 square color. We'll set this equal to 0.2, 0.3, 0.8, like we did before. We'll just have it as a vec3. I mean, the alpha's going to be 0, so we might as well just have it as a vec3, which means we'll have to add the right function. So we have this as a
Here, what I might as well do is and then there's the color pixel search. Um, I should be able to just set the color. I guess while the shader's bound. Upload after. Back for um what is it? 0 F0? What? Oh, yeah. Oops. And will that work? I don't know. I think it'll work. Might not. Might. Yeah, kind of freaked out. Um, I don't think that needs to be every time, because I know for the view projection that only gets uploaded when it's changed. Where was I? Hmm. Okay, he is doing that on upload though. Um, which I guess I could do. Ooh, I forgot to bind. Oh, that's on start. Oops, I didn't go down far enough. I kind of just saw that. I was like, yeah, that looks like something that happened on update. Nope. Go down a bit further. Um, yeah. Okay. Um, why would it be null pointer on start? Because init visual data is run. Where is that run? Oh, okay. Yeah, it's like, well, that's run on start. Nope, I was doing the shader stuff up here, and the shaders are made down there. That doesn't work. Okay.
We'll do the upload here. Do the transform and the position inside here. So this will just kind of, again, if we had a material, it would be in the material, but we don't, so it's here. But when we have materials in
Yeah.
the future, we'll rewrite this. We'll get rid of the red color and the blue color from here because we don't need them anymore. And then the final thing is we need to create all these functions. So let's go ahead and make that happen. So inside
I
OpenGL
know he's
Shader,
up.
all these functions. So
Hmm. I'll keep it.
let's go ahead and
I mean, it
make
makes
that happen.
sense if you don't
So
care about
inside
the
OpenGL Shader,
opacity. I don't even
we're
know if
going
you can
to
set that with the
basically duplicate
fourth
this a bunch of times. We'll have upload
element
float,
because I
upload
tried
float 2,
changing that
float
and it
3,
didn't do
and float
anything.
4. We'll probably have an int as well, so upload uniform int.
I can
We'll
do the
definitely need
voice
that
talking in the
for
background.
things like samplers
Um,
when we need to upload those. Int 2, int 3, int 4. We probably won't make functions for that just yet. We could, definitely could. I'm just trying to think what on earth they'd be used for. And int 3 would probably be quite useful for like bone indices, but again, we're not dealing with animation anytime soon, so I think that's too useful right now. So I'll deal with that in the future as we need it. I'll do mat3 though, because that could potentially be useful. Okay, so we've got all of this sorted out now. So we've got all these. I can just right click here and use Visual Assist to create all of these things. Okay. And then back here, create all of these things. Okay.
int, single int, uh, floats 1 through 4, mats 3 through 4.
And then back here,
Oh, let's do this in an order that
and
makes
soon put them in the right order,
sense.
which is great. What I'll do is just copy this code absolutely everywhere. So
The double
this
was above
this
the
location
float
should,
because
as I mentioned last
when
episode,
I
should already
initially
be here
made
because we should
the
have
math
passed the shader, got
library,
all the shader values out.
it was based in doubles,
We'll deal with that
and
in more
then
depth in the future for sure.
yeah, when I
But
made
for
this
now, we'll
custom
just get
math
the
code,
location
and
every
then
single
coming,
time,
well, two
which we
reasons
shouldn't
I
really notice
changed it.
any kind of
One,
performance
I did a bit
decrease
of
from that,
research
even
in
though it is
and
the
learned
most efficient thing to do, just because we're not
usually
doing large scale rendering
I don't
on
know
the
about
kernel.
other things, but
So
OpenGL is
don't
working
worry
with
too much about
floats
that if
anyway,
you are
so if
slightly
you
worried.
just send it doubles most of
Okay,
the time,
2F and 3F.
it'll just have to convert them into
What you could
floats.
do is actually
So
cache
it's like,
these
oh,
locations as like a quick thing. You could either
okay,
like retrieve a list of active uniforms from
I
OpenGL.
guess.
Um,
And then
a quick
two,
way
if
that a
I
lot of
want to
people
make it
tend to
like
do is actually cache the uniforms in
interchangeable
like
with
a
GLM,
map, like a hash map,
um,
so that you don't like, and then the hash map
they
is
have to
based
like
on
kind
the
of work
name
the
of the
same
uniform, and
because
then
GLM is based in
the actual
floats
value
by
is the
default
location. So you can just
for
easily
its
kind of
like
retrieve the
vec2.
location only once and cache that value, and then reuse it.
But that
So
was
this
kind
little
of like
location is
a
not going to change.
not so
I actually
much the
have
reason.
a video. I think
It
yesterday I
was
probably
more
released a
just
video
wasted
on
effort
that. I haven't
on
made the video yet, but I'm gonna make it and then release.
by like sending it doubles and then yeah. Oh, where is it? 2, 2, 3, 3, right? And then you float an int. Oops. And then for that, it can just be, well, I guess int float double. I'll just call that v. Float v. Oh yeah, I added like more songs to the beat track. It's pretty close to 4 hours now, I'm pretty sure. Um, I'd have to like double check. It's this whole process. I really should just copy and paste the code I use for it, but I've never felt like it. Basically, I just I open up the playlist page, and then I open up DevTools. I get the class name for the elements that hold the durations, like the minute colon second. Um, and just query select all of those, limit it to the however many videos there are, and then just parse that into minutes and hours for each and add it all up. Because YouTube has decided that it doesn't want to tell you the total runtime of your playlist, and I don't feel like getting an extension for that. Um, yeah. Okay, next is I think it'll be less effort to just do this and then this and then this. Right? And then I can split it back up if I want. And then now I'm missing a few functions. I might as well have him
It, and actually this
background.
video will be released after I release the other video, which is weird because I haven't made the other video yet. But long story short, OpenGL caching uniforms video up there. Check it out if you haven't already. If you want more details about how to cache these uniforms and stuff, because I thought I'd make a specific OpenGL series video
Upload.
about that. Okay, so value, this becomes value.x, value.y. In case
Um,
I'm going a little bit too fast and you're not following along, all I'm doing here is just creating
nope.
very, very
You
basic
are
functions that
a-okay.
are pretty much the same, but they actually deal with different types. So in other words, we're dealing with a 3-component vector here, a 2-component vector, a 1-component vector, or just a float, and then
GL
like a 4-component vector, like a vec4, which is just
uniform.
4 floats that we're uploading to the
Hello.
GPU in the form of a uniform, so that we basically can upload any type of data we want and not just float 4s and mat4s, which is what the only thing that we could do before. So this becomes 3FE, and that is literally the only thing that changes. Amazing. Okay, really simple. Make sure that you don't make any mistakes. 4, 3, 2, 1 sounds good, and 1i, of course, for the integer.
Okay, it's
Okay,
one
that's
eye.
it. That's all we have to do.
He did that way better, way faster. Oh my god. One eye tab. Come on. Um, location V. Program. Um, okay. Oh, and do that. But this one is a float. And that means that's probably F. This one's a double, and that means that's probably D. Oh, right. Uh, I copy enough, select enough. Um, and from there, it's 3, and then I just select a few 4s and make them 3s. Uh, and then for these, I need 2 and 4. I just 2 and 3. Surely, oh man, I just need to. What does this take? Okay. I guess it figures it's so much data. Yeah, why the fuck would you pass them all in at once? Or not all at once. Yeah, pass them all in at once instead of doing this shenanigan stuff. Uh, um, like that. Get rid of that. Um, yeah. If that's freaking it, usually pre-make 5, yes. I can do that. Nothing changed. Guess I could close and open. Yeah, because Visual Studio is a wonderful piece of software that always recognizes when you've defined functions in another file that then tie into a header file. Um, okay.
Now we have all of these functions, and we can obviously use all of them, like upload uniform float 3, for example, should be
Yep,
completely fine.
all of
Here's the
them.
function. Okay, so that's how that works. Let's go ahead and add this
Where's this
M
being
square color vector to our
uploaded?
IMGUI controls. Really, really easy to do. I don't think we've done that
I
before
should be
in
able
IMGUI, but I'll show
to
you how simple it is. We basically just do
change
IMGUI begin to
this.
make a new window. I'll call this window settings. And then every IMGUI begin needs to have an IMGUI end as well. And then in between that, we put basically a list of UI controls that we want.
And then this
So
should work.
what we'll do is we'll make a IMGUI color edit 3, which is just a little kind of color edit UI control that we can click on to bring up a color picker. We'll call this our square
Yay,
color,
that worked.
and we'll give it a GLM
What are you
value
doing?
pointer,
I'm
which
not
is going
looking.
to be our square color,
What is a
just like that.
value
Okay,
pointer?
and for value pointer, I think we need an include, which is this one. I'm just stealing it from OpenGL Shader, just like that. And that's it. Like these.
Was that in? Oh, it's in the layer? I mean, that kind of wouldn't work. My event system is in a cult. It's not. It's queued. It's it's like, hey, this happened, but not right when it happened. It's like, oh, it happened a bit ago. Um, might not be the best. I might have to switch to like immediate handling, which I would be able to do pretty easily. Um, and in fact might be um, I don't know. That would wipe out the event system handle. Well, really, it would merge event system handle and event system add event. Um, so instead of like queuing the event, you would just immediately handle it.
These three lines of code are going to give us a nice little UI so that we can change the square color at runtime. And these three lines of code are going to give us a nice little UI so that we can change the square color at
I
runtime, and
didn't
everything
even
else should
pay
work.
attention
Let's hit
that's
F5 and see what happens. Okay, so
the
that did not
GUI
work as
thingy is.
expected. All of our squares are actually black, which is fantastic, but you can see that at least they are in the proper positions, which means that obviously the transformation matrix and all that stuff worked. So for some reason, our flat color shader did not seem to work with
Hmm.
this. So let's take a look at this. Oh, it's a vec4. So we change it to a vec3. Make sure that you don't forget that change. And then over here, we'll just do vec4 ucolor and then 1.0 for the alpha. Let's hit F5
The
and
alpha.
this should now work. All right, and as you can see, we have our Hazel and everything with
Wow,
this kind
blue.
of UI control here with the square color. So what we can do is now just click on this, brings up a color picker, and you can see that we can change it to really any color we want. And this all of the squares are updated with that color. So definitely very cool, and shows
Yeah,
that
see,
all of
but
our uniforms are in fact working dynamically.
what if
All
I
right, so I
put
hope you
in the
guys
work
enjoyed
to
this
make
video.
that?
If you did, you can hit that like button. You can
I
also
just
help
took
support
like
this
a
series
whole like
by going over to
I don't know, four
patreon.com forward
months,
slash the
6
channel and get
months.
access to a lot of really cool things. I've started doing this new thing on
Like I
Patreon where
understand
I
he can't
actually
really
make
do that because
exclusive
he's making
videos
a kind of
just for patrons. So
digestible
this
tutorial,
isn't
but
like
like
some
I'd be
kind of
totally
massive
down to
like
like
conspiracy
just
of oh my gosh,
sit
Cherno
down
suddenly
and
releasing all of his like really cool
UI
content
code,
just for patrons behind a
you know?
paywall. No, no, no. What I'm actually doing is just making little videos as I work on the real videos, just with little notes. So while I'm developing Hazel Dev, right, which is kind of my personal Hazel development branch, which you can also access through Patreon, which is where I've got like the PBR renderer and all of that stuff.
Yeah,
Or I'm
his
just kind of
Patreon
just thinking about
if you want that.
another video that I'll make. I'll make kind of like a develop. Hey, what's up, guys? My name is Chano. To check that on my phone
But
because how all that system works.
sit
Okay,
through
so enough kind of
the
fluff,
video all
enough of
the way
that
through,
crap. We're gonna actually
but
get into it now.
I
So
feel like that wouldn't be too interesting,
what is going on right now with our code? Pretty much everywhere
and I
we're
want to
using
actually work
this
on
kind of
stuff.
shared pointer thing where, just we need to create a shader. So it needs to be created on the heap. So what do? We encapsulate it inside a shared pointer object for two purposes. First of all, because we want to control the lifetime of this object. We want to somewhat tie the ownership to Sandbox app, but also make it so that if this app kind of gets destroyed or any scope that we're dealing with gets destroyed, this object too will get destroyed because it's a shared pointer, provided there are no other references to it. Now we could have used a unique pointer here. No reason kind of not to, right? You would think just type in unique pointer, scope it. I think some people actually did suggest that in the comments, that why is this not a unique pointer? Because it needs to be, clearly the lifetime is tied to this. It can't exist outside of Sandbox app or anything like that. Should we be using unique pointer? Now, smart pointers are interesting because they kind of provide us with a system that helps us, right? They're there to help us. They're there to say that you're not going to actually call delete, are you? We'll handle that for you based on the kind of traits of the object that you're kind of shoving into that smart pointer. Now, I have a video on smart pointers. I even have a video in the C++ series specifically about what I think of smart pointers. Now, I think that has changed, and that video I think isn't necessarily about what I think of them, it's just how I think they should be taught, because I think there's a lot of emphasis on smart pointers these days, and people getting really angry in comments, in my comments, being like, why did Cherno just write new? Did Cherno just write delete? Why? That's wrong. The point is, smart pointers are fantastic. I wouldn't live without smart pointers, because if smart pointers didn't exist, I would just write a smart pointer class and we would just use that. But the problem is more, it's kind of deeper than that. The problem is the fact that it's not just about new and delete. It's not just about abstracting that away and especially automating that delete part. It's 50% of it, if not more, is about ownership. It becomes a question of ownership, right? This is now owned by something. If we make this a unique pointer, guess what? That means that this sandbox class literally owns that shader, right? Because if it doesn't own that shader, and some of the sandbox class is the example layer class, but the point is that
Okay.
example layer class literally owns that shader. Why? Nothing you can do. You can't copy it. You can't hand over ownership. That's it. When that example layer gets popped off the layer stack because the application's closed, because we want to transition to a new level, because we want to do anything like that, right? As soon as that dies, that's it. Our shader's wiped off the face of the earth. If the memory is released, it could be instantly reclaimed. It's gone, right? I want to suggest that that is actually an issue. That's a problem. We can't have that. We literally can't have that. Because right now, if that were to happen,
think we'd probably be okay. But you have to consider the bigger picture. Let's take a look at a renderer. Let's have a think about what our renderer would be like if it was actually, a solid renderer and not just like a bunch of functions. And I mean, we're on our way. We're on our way. We're gonna get there. But right now, this renderer is, very, very bare bones.
We're
If
gonna
we had a
get
real renderer,
there.
let's have a think what that would look like. Okay, so we have a renderer submission, right? We call Hazel renderer submit. What does that do? Well, at the moment, it takes in a shader. In the future, as I said, it would take in a material potentially, but right now it takes in a shader. What have we done? We've
We could
submitted the
really
shader
go
for
for a
rendering. We've submitted the
times
vertex for
three
rendering.
right
A vertex array,
about
that's also
now.
an asset, right? Any kind of asset is going to be a pointer, essentially. It's going to be a heap allocated object, and eventually probably not allocated in the heap, but allocated in kind of our memory arena or something like that. Vertex array is
He's just
a
gonna talk the whole
it's a
time.
resource. It's an asset that we need to
Okay, no, he
actually
does some
use to
coding.
render that, and we have a
I'm
transform.
not
Now,
even gonna
a
use shared
transform that's a
pointers. I
mat
don't know why
for. I
I'm
mean,
on this
arguably, you
video.
could just not really a real asset. You could, if you wanted to, 64 bytes of data, you'd probably copy that and you'd take. And our reference we're going to call ref. So let's think about all of the core stuff, and I'm going to add a namespace called
Ooh la
Hazel.
la.
Right, nothing too special there.
Adding to
And then what
core,
we're going to do
always a
is
good
create
sight to
essentially a type
see.
def, so we're going to use using for our two different types. So scope being a scoped pointer, right? So this will be a unique pointer. And then we're also going to create ref for our ref counted object, which is a shared pointer. So because, of course, we want this to work with templates, that's why we're actually using, apart from the fact that using is the thing to use these days, it also enables us to actually define this as a template. So we have a template, type name T, and then this just goes here. And now what we can actually do is use scope with a type when we actually make it, whenever we end up using it. So this is obviously vital because otherwise this wouldn't really work. We'd have to and I mean, that's the other thing, like you could definitely do stuff like, let's just say we had a shader class, right? Instead of writing ref shader, which you currently have to do, and this is as opposed to, std shared pointer. So what is basically done is enabled us to change this code into just simply writing ref shader. And if we're outside of the Hazel namespace, we'll have to do that. Kind of shows you very easily that it's a Hazel ref, or for a unique pointer, we would do scope, right? But apart from doing that, you could also create your own using where basically shader ref is a new type that is that, right? And if you do that a lot, maybe that might make sense. But that's not something that we particularly care about. It's another common way to do this, where basically you just define a new type,
Like, I
at the end of
guess,
your shader
but I
class,
feel like that's
especially
kind of pointless.
shader.h, I mean, we could potentially
And
just add like a using shader ref
if
equals,
you really haven't added
shader
anything
std shared
on,
pointer shader
you
or
might as well
whatever,
just
or
be
you could
like,
just simply, in this case, just write
yeah,
ref shader. But I
this
think
is
ref
a
shader is something
shared
that's
pointer,
not too
this is a
difficult to
unique
write, and
pointer.
I don't like creating a billion different types. So because of that, you can basically just stick with this. Now, this is all the code that we need, right? It's really simple. What it means in the future is we can simply just change this scope thing, to be an actual template. So type name, what am I doing? Template, type name T, and then, class scope or whatever. And then we can just make a class out of it if we want to, and we don't need to change anything in our code base as long as where we put files like include memories, we're in the sampler ref. Of course, with the possibility of kind of a finer grained fashion than just by having it as a shared pointer. But this is a fantastic start, and if you just need to have a quick little asset system in your game engine, honestly, just use shared pointers. They're great. So that's pretty much done, I think, for this class. Really, all I'm gonna do is just search for std. And I don't think we've got too many of these, but std shared pointer across my entire solution. Maybe the entire solution was not necessary. We actually do have quite a lot of them. Oh, of course. Well, we use them everywhere, right? For things like this. So this just becomes a ref, and you can see that because we're inside Hazel, we don't need to do anything. We can just change this to be ref. And I guess we'll just work through all of these basically and change them all to be ref. There might be quite a lot of them. Okay, so we have we have them up here as well. Now, note this, right? I'm not changing them here. This I'm leaving as std shared pointer. The point of this is not to just rename the standard template library and just create our own version of it. No, that's silly, right? I mean, we're not gonna,
Okay.
we could type def string, std string to just be like string with an uppercase S. And that would be like our string class, right? No, we're not trying to do that. What we're trying to do is shed some light as to what is like a Hazel reference and what is like, an std shared pointer. This is a log thing,
I
right? We're
guess.
still going to use shared pointers in our code if we want to, but for things that are explicitly Hazel only, right? Things that maybe in the
Sure.
future would be
Okay.
handled by an asset
Yeah.
manager. So in other words,
I mean,
assets, right? That's the kind of
see.
stuff we're
I
trying to
decided
bring
to do
in
that with
to
a
refs and like, scope
specifically with
pointers
events.
as well. So that's why we're gonna just
Um,
leave these alone. Okay, let's see. Vertex array, for example. See how this is returning like
where's
an index
that?
buffer?
Where's that
Clearly,
happen?
that index buffer
Um,
is simply it's
should
like it's
happen
an
here
asset. So we
somewhere.
just return a reference, and this is
Yeah.
returning
Event data,
a vector, and
and it's
we
literally
need
just
this
new.
stuff as well. Vertex
And
buffers
then
and
it's
index
like,
buffers.
yeah,
Those are
this will
also
be deleted without you having to
assets.
worry.
That looks pretty good. Let's look at
Um,
render API. We have this here, so I'll just rename this. You guys kind of get the point of this. Could probably just cut the video here and do this myself, but
yeah.
I'll still go over this just in case we run into anything fun or unusual. Okay, and then render CBP. We rename this stuff. Really does make our code a lot cleaner as well. That's one of the things that I like about doing this. Um,
Yeah, that
okay,
kind
we've
of
got a
does
bunch of
look better.
these
But you could also
things. This
just
needs to be a hazel ref.
using standard shared pointer and using unique pointer,
Got a bunch of
and
these
then you
for
just get
our
rid of the whole STD.
data that we create inside our example
But
layer.
that's kind of stupid as well.
But that's just easy, for this though, to be like 100%
I don't know.
sure.
I don't know if macros are like
Okay,
the
so now the
in
only
thing to
references you can
do
see in the search
with
are inside
C++.
log and core, which is
Not that
fantastic.
I
So we're not
especially
using
care about that,
smart
because
pointers basically anywhere.
I think this
We're not
language is a
using shared
little
pointer anywhere
silly.
except for the log
Um,
class. We're just simply
but
using
whatever.
hazel ref, which is pretty cool. All right, obviously we're going to try and compile this
Oh
code, make
yeah,
sure that we
but
didn't make any
this add
mistakes,
event,
and I mean, it should compile and run
I have this
as
if def for
usual. All
logging,
right, so we get no compile errors, and now if I try
which
and
is
run this
the
code, we
thing
should
that
get
spams
the
the
same result
console.
as last time where we have our kind of
Um,
world here and everything
and
seems to be working
then
correctly.
if
I hope you
there's
guys
a
enjoyed this
the
video.
event
If you
queue is
did,
just a
hit the
link
like button.
list,
It can help support
because like
this
why not?
series and everything I do
I don't
here
want to
on
have
YouTube by going to patreon.com/thecherno. Huge
a
thank you
vector
as
for
always
that.
to
That
all
would
the
be
lovely
like beyond
patrons that
stupid.
make this series possible.
That's what
Start
I
doing new exclusive videos,
that's what I
especially
did
last time where
when I
just simply if
initially
you
wrote
support even
this.
for as little as $3 a month, you get access to a whole bunch of exclusive
I'm
videos.
pretty sure.
In the last one, I actually showed a bunch of like the Hazel development branch, and I think that I actually am going to put that video up. It might already be up. Just kind of share that exclusive video with kind of all of you in general, but there's just tons
But
of
yeah.
stuff to kind of explore there, as well as access to the Hazel
Okay.
development branch. It's going to be a long episode. If you see me drinking coffee at the beginning
Ooh.
of a video, in fact, if you see coffee in the thumbnail of a video, you know it's going to be a nice long episode. Hey, what's up guys? My name is cherns. Welcome back to my Game Engine series. So last time we talked about smart pointers, references, we talked about assets as well. Check out that video if you haven't already. And today we're going to start off by
I've
actually
checked it out.
creating probably our first actual asset type, right? Like we've got shaders and we kind of consider them as
What?
assets potentially, and geometry that we've kind of created in our engine. But today we're actually going to load a file from our computer. It's going to be any file that you guys create yourselves. We're going to load that in and we're going to display it in our engine. So this is really exciting.
I might have to start a new
if you haven't watched my
branch.
video on what game engines actually are, literally the first episode of this series. So if you haven't watched it, I'm
Here, let me
quite
check
disappointed in you.
this.
But in that video, we talked about the fact that engines are really just these kind of
Because I
things
can
that
tie
we
this
have.
in
We
with
write
the
all the
current branch.
software.
It
This
kind
kind of
of
engineering effort goes
matches
into
up,
this
and that's
software,
fine.
this program, which takes data from our computer and transforms it into some interactive like graphics adventure that we see on the screen. That's really what a game engine is. And today we're finally taking in a piece of data that isn't
But
generated
textures
from
is
within
really
like
kind of
our
its
engine or
own
anything like that.
branch,
We're
I
going to be
feel.
loading in a texture, just a normal image file, and actually displaying it on our screen.
I
So
don't know.
that's super exciting. So I have a video on textures in OpenGL, so check that out as well if you haven't yet. That's going to be kind of the basis for what the kind of code we write here, although
What
the
are
code we write here today is going to be a
textures?
little bit different, specifically the OpenGL code that we write here today. I mean, we're also going to set up like our standard
Or is it
kind of abstraction and everything like that,
holding
as we've done with
space?
like
Okay,
different
I guess I have to
renderer
be
primitives, like called
focused.
like vertex array and shader. But specifically, like the OpenGL code is going to be different because we'll be using a bit more of the updated API, which I'm not quite sure. Windows 10 wants me to restart. What's up with that? By the way, like seriously, almost makes me want to switch to Mac. You know, not really, but almost. This whole OpenGL. I mean, we're also going to set up like our standard kind of abstraction and everything like that, as as we've done with like different renderer primitives, as I call them, like vertex array and shader. But specifically, like the OpenGL code is going to be different because we'll be using a bit more of the updated API, which I'm not quite sure Windows 10 wants me to restart. What's up with that, by the way? Like, seriously, almost makes me want to switch to Mac. Not
Okay.
really. And what we did
Let's be
like
on
in
the
that OpenGL series, specifically to do with texture loading. So I want to talk a little bit about what
so like
textures
tuned
actually
out and he's
are and
like,
what they're used for
"Duh,
in a game
I want to
engine,
switch to
because
Mac. And it's like,
textures are
what?
extremely powerful. Textures are very powerful. Textures are more than you might think they are. You might be used to textures just being like, okay, well,
Yeah,
I've got an
textures
object
are
like this
really
bunny, for
powerful.
example. This is why I've got the bunny here, so we
Gonna
can do things like this.
I'm gonna
We've got
fucking
this
grind that
bunny
bunny
here, and I
down
want
with
it to go
some
green, and I want
textured
it to kind of have
sandpaper.
ears, and maybe some other color, and I just want
Ah,
it to
that
be
was
more
really
than just like
violent.
one solid color. So how
Okay.
do I do that? Well, I'll just kind of create this 3D model in a program
While
such as
he's
Blender
talking about
or
that,
Maya
might
or
as well
3D Max or anything like that, and then I'll
um
texture it. I'll add like I'll create basically, I'll unwrap the UVs and I'll flatten it onto a texture and
unwrap
I'll
the
paste that in
UVs.
Photoshop, and I'll just have my nice little bunny. And that's
Um,
correct. I mean, that's probably the first use of textures that comes to mind. But textures can be a lot more than that, because what textures actually are, um, what they actually are is just a buffer of memory that we've taken and uploaded to our GPU, and now it's stored in our VRAM. And we can access that buffer of memory in our
I love
shader,
you,
specifically in our
VRAM.
fragment shader, in our pixel shader, when it's time to determine, what color to
Yeah,
shade
I'm
the
on a.
pixel. So because it's just a buffer of
It's
memory,
kind
we
of
can upload
great
anything
that
into
for
it. I talked a
testing
little
this,
bit
it's just kind of like
about
a
buffers,
cubic
like our
triangle.
index buffer and a
Because
vertex
I'm on a
buffer,
dinky
and our
little
vertex
laptop.
buffers, and just for
Um,
positions, we can put any kind of data we
I
want
can't
into there.
really
Textures are exactly the same. You could literally
like.
put anything you want into a
I've thought
texture,
about it,
and then
like
when you
streaming
sample
other
that
things
texture,
besides
apart from
coding.
getting all the
I think
specific
all I
GPU
could
technology that
manage
goes into
is
sampling a
Hollow Knight
texture and determining, like, what
and
color to
Lego
kind of
Batman.
interpolate it into, if we're doing magnification or minification, filtering, or anisotropic filtering, or any other kind of filtering,
I
when we
think,
actually
yeah, that'd
sample
be
the
it.
pixel and we determine what color to return from that texture image, we get all of that bonus kind of data if we want it. And then also, we just have the ability to, in our shader, just select that
Ooh,
kind of specific region of a texture and be like, I want to know what the value is. Now, true, in many cases, the value is the color. For example,
um,
maybe our bunny's fur color is brown, so we'll just get that brown color out, and now our bunny will be rendered as brown. However, we can encode any kind of data we want into it. A really good example is normal mapping, right? Where what we've done is we've wanted to keep our bunny model kind of low poly, so that we don't have to just have this hugely high poly,
is that how you
very
spell
heavyweight, very
amend? I
performance,
forget.
expensive, like model, 3D model with all of these little details. Instead of doing that, we create a texture, which is just basically a little collection of values which define more finely the normals that go into this bunny. And that high resolution texture with all that kind of normal data, and it can actually
Yeah,
help our bunny look a lot more detailed and a lot more realistic, because when it's time for us to do our lighting calculations, instead of relying on the
I feel
vertex
like he's
normals,
talked about
we
this
can actually
before.
just go ahead and sample that texture and figure out what the normal actually is for a given
I used doing
pixel,
this over
on kind of a
multiple
per
weeks.
pixel basis,
That's fine.
instead of like a per kind of vertex and then interpolation and then all of that stuff. So
Um,
really powerful
all
stuff, and
right.
we'll cover normal mapping, of course, eventually in this series as well. But that's just a little bit of an example, and I could go on and on. I mean, there's, in physically based
Pull
rendering,
request
PBR rendering, there's
time.
like, roughness maps, metal maps. There's all this other stuff that you can do as well to define what areas of the bunny should be shiny and what areas should not be shiny, right? And all that is it's just a texture, but really that texture is there because we want to look up a value when rendering a given
And
pixel
then I
inside
always
our
like
shading.
to look at
And that's kind of what a texture is. And again,
previous
like, to bring up
pull
physically based rendering
requests.
again, to give you one last example, there are certain mathematical operations that are very difficult to do in real time, so we can actually do them offline and then store the results in a lookup texture, in a LUT, essentially, in a texture, right? And then all we have to
Okay.
do is, in that texture, we've stored all of these
Oh,
already pre-calculated values. We can just extract the one that we want, and that's it. We suddenly don't have to do that calculation at runtime. That's what we do with like a BRDF LUT or something like that, right? So that's another little example, and we'll get into all that stuff in the future in a lot more detail. So if you don't
that's cool.
understand any of this, that's totally fine. The point that I'm kind of trying to drive home is the textures are so much more than just a bunch of colors that we use for directly taking those colors and then applying them to a 3D model. All right, so now that we've discussed
I mean,
just
yeah,
what
it just
textures
kind of
are
sounds
and
like a
what they're used for in a game engine, let's talk about what we're actually going to do today specifically.
Texture,
So what I want to
material,
do is
whatever.
load
It's
an
just
image
data
file from my computer, and then
that's
I'm going
kind
to
of
render that
some
essentially
of
on
it
like
is
the quad
associated with
inside our engine. That's it. I mean, how hard
like
could that be? There's actually a lot of components that go into
I
that.
don't know
First
how
of
to
all,
describe it,
we
but
need to
I
talk
I
about our
kind of get it.
geometry. So what is needed to display a texture on our computer screen, right? Like what data do we need in the geometry? And specifically what I'm talking about is we need texture coordinates. Again, I don't want to really go too deep into this. Check out the
Um,
OpenGL series video on textures because I
so
think that
is
goes a lot deeper than what
this
I'm going to do right now.
description?
But essentially, what we need to do is
Yeah,
modify our
noble
vertex buffer so that it
files.
actually includes texture coordinates for every
Um,
corner of our square. Then we
window.
also need to have a we need to change our
Yeah,
shader around so
okay.
that it takes in like a sampler 2D, which is
Move
basically
that over
just
there.
a 2D
Item
texture slot.
rendering.
And then we need to create a texture class, obviously, that will load that file and create and upload it to our GPU. And also we'll get a renderer ID out of that we can just bind at runtime
Here's
using an API that
this.
we'll create. And then that, I think, should be it. So it shouldn't be too difficult, but there is a lot of work that's going to go into this. I don't want to make this episode too long, so I'm going to just go through it as fast as possible. It
Objects.
should make a lot of
Is
sense. It should be
object
really
start word
straightforward.
items?
If
How
it's
does that
not,
look
then make
for
sure
a
that you check
system
out that
from
OpenGL
collection
texture
of
video.
items?
And if it's still not clear to you, leave some comments
Sure.
below, and I'll try to make additional videos for things that I might have missed that you might be that might just need a bit
Notable
more explanation.
files.
So without further ado, let's
I
jump
know
in
there's
and
a
take a look at
very
textures in our
particular.
engine. Okay, so the first thing I want to do is prepare this area kind of for texture. So we're not even going to touch textures yet. We're just going to make everything else basically ready to go. So if we take a look at what the
Um,
Hazel engine
and then I
is
can just
at
look
this
at
moment, all it
the.
is this triangle. I think I'll get rid of that triangle. It's getting a bit annoying. We've got this grid, which is fantastic. We might keep the grid, but what I want maybe instead of this triangle is a nice big square
Oh
where we can
yeah.
actually render our texture. So to render a texture, we need to render it on some kind of geometry.
Oh,
So we've got a
that's why it looked weird.
vertex buffer here, which contains a square, which is fantastic. That's what we'll
Yeah, that makes
use.
more sense.
However,
Okay.
what I'll do is I'll hide this triangle. So this is us rendering the
Um,
triangle. I'll just label it here so it's more clear.
camera.
This is us rendering our grid. Literally all we need to do is take this submission, and instead of
Hold on, what are you
submitting,
doing?
we'll change the transform around so that instead of it being tiny, I think what we're doing is we've got a position, which is fine. We can just leave it at the origin. However,
He, he was he was like, yeah, just add a transform, and kind of from my experience, if you're just in the situation where you're like, I'm gonna need to add on more parameters to this, you should probably just have it in one parameter of everything you'd want to pass, because that's usually easier to change later, right? Adding a member to like a class or a struct is easier than adding a parameter to a function. Um, in some ways. So yeah, I that's basically what this is. I just decided like, hey, yeah, scene info, it has the camera, um, has items, and you'll notice like I'm not making all the members private. First got into the swing of it and like, okay, camera private, public, getter, setter for it, and then it's like, what am I doing? Just make it public. And like you could be like, but like, what if you want to change it later? And then I'd be like, I'll change it later. It's I really don't care if this is changed. I don't care if this is changed. I do care if this is changed, kind of. Um, just 'cause where's that? Um, because there's this override VP cache thing. Um, if you were to push back items, then it wouldn't be able to do the and then the VP is just view projection, right? Matrix. It would have to just calculate that each and every single time. Or like, I guess not, but basically if you add an item or remove an item, I guess that wouldn't really, it would still need to upload. I don't know. Um, I guess for not for removing, but if you were to add one and it didn't override the uh EP cache here, and it me so it wouldn't like recalculate. If I just took this and did that there, it would only upload if the camera changed like position or something. Yeah. And then if an item was added to the scene and this overwrite wasn't there, then the item that was added wouldn't have the view projection matrix in its shader, and then it wouldn't show up until the camera was modified and then recalculated. Yeah, that's what I'm trying to say. Um, yeah, yeah, yep. It should be right on. Okay. So, and what is this? You can continue, Mr.
Over the scale, we did set to 0.1, which is kind of small, obviously. I think one is the size of that triangle, which was also a little bit small. So what I'll do is I'll just copy and paste this scale transform, but I'll change it so that instead of 0.1, it's 1.5. So
How
it's a
did
little bit
I?
bigger than just 1.0
Okay,
scale. So we're scaling it up a little bit. We'll still keep the flat color shader and the square
it's
vertex,
not the
great. So
header
if we
file.
launch this right now, we are setting the color to blue here. So we should just
Is
get
that
kind of like
really
a large
notable?
blue square kind of in the middle of our screen. And here we go. So there we go. We've got this blue
Not
square. Perfect. So now
really.
what we want to do is instead of render the color
I didn't
blue, we
especially
want to sample each
change
pixel from a texture so that we actually
anything.
see our texture
I'm
on the
not
screen.
including that one.
So to do that, the first thing we need to do
Like functionality
is
wise, I didn't change any.
change
I
up this
changed the
vertex
code,
buffer so
but
that
I
it
changed the
contains
code so
texture
that
coordinates, because without texture coordinates we actually
it
can't
would
render
work the
anything because we
same
won't actually
because
know
other
which
things
areas of the
changed.
texture need to be sampled. So
Or
for
you can
the
call
bottom
that
left corner, this is
notable
the bottom left corner, we'll just use 0, 0.
um component.
For the bottom right corner, it'll be 1, 0. So we're just going along the positive x-axis here. I'll just copy this quickly. For the top right corner, it's just going to be 1 for x and 1 for y. And then finally,
I'm really
for
good
the
at
top left
spelling.
corner,
You
we're
can
back
tell
to
because all of the
0x
red
and 0
lines, that
on
means I spelled it
y.
right.
Now this is expanded now. Instead of us having 3 floats
Oh
per
no,
vertex, we have
my
5 because
4
we have 2
p.m.
more
alarm to
for our
wake
kind of
up
2D texture coordinate here. Let me
is
just
going
check
to
that that's
go
right.
off
And yep, that looks good. Okay, so basically, I
in
mean,
like
the
10
way that you can
minutes.
follow this is if the negative zero point 0.5 is negative, right? If the
Yeah,
zero
my
point
sleep
0.5 is
schedule has
negative,
kind of
then
been
you actually want it to
atrocious
be
because I've
0.
been working
And
on
if it's
this
positive, then it
um
should be positive. It should be positive 1, right? So 1 for positive,
GFW
0
shader.
for negative.
Yeah,
And that way we can quickly check to make sure that everything is correct, and it is. So we need to expand this now. Obviously, we still have square vertices and the size of square vertices, so we don't have to touch anything here. For our layout, because of our beautiful
I should not have had that in the background like that. It's fine. I'll just actually sit down and then watch it times two in a little bit. Um, GLFW window renderer. What is copy? Is that copy the hash or the file name? Copy's the file name. That'd be really useful. Almost copies the file name. Window renderer. Renderer. Um, input. Yeah, sure. Nope. I was trying shortcuts for like, because Visual Studio has Control D, Visual Studio Code is Alt Shift, and then up or down. So like, if I could just duplicate the line, that'd be really nice. This is nothing. Let me like double check predefines. Did I misread? God damn it. Cause I did. I totally did. I thought that was the That's fine. Cause like before for like debug stuff, I had uh this and I saw def and then I saw the name. I was like, "Yep, got to delete that." I did not have to delete it, in fact. That was incorrect. Um fix if def uh free at oops. That looks stupid. There we go. Let's actually I do need to um it'll be there when I refresh it. Um yeah. Input, what else? I know input kind of why is that in there? I'll just sneak it in. It's whatever. Um yeah, I didn't really call that notable. Um hmm, I'm just trying to look at it so that there's something in my mind to think about because I'm gonna have to like summarize these in their own little sections. And I'm like, I don't know. I just figure I might as well go through the effort of doing a pull request, even though there's one person I'm like working on this with, and he like kind of looks at him. At least, okay, that's not really fair. The last one he kind of looked at because it was like I basically half the thing, and I kind of told him it'd be funny if he just like, because there's the GitHub what is it, quick draw achievement. So I was like, hey, maybe if you like, review this pretty quick, I get that. And I was like, yeah, I'm not reading all that. And then he just, yeah. But like, I think usually he does, read them. I don't know. It's not like I can even say usually because it's been a year since I changed anything. Um, but yeah, it's good practice and it's like a clear trace of, hey, this is what's been kind of worked on, like the broad strokes, so you don't have to go through every single commit message. Um, yeah, there's no C++. That's right. That's why that was first, because there's no second. Uh, After shader, how do I order it on here? I don't feel like pulling up another one to check. Windows changed because the frame rate thing and because it stores the scene info. Or I guess that's just because I set the default value for that to null pointer. Um, hmm, to do docs. What I do here, this is the actual delta time change. Close that window, render. That looks like C++, and I'd imagine. Imp item rendering. Um, was that just the, okay, that was just the header file. I guess there is no C++ file for that, because I'm pretty sure that's an abstract class, and it doesn't really have any non-abstract, non-inline functions, methods. Yeah, math operators. Um, so some of this probably pull request with the math stuff. It would have been really tiny, but it could have been. Um, I don't know. I just figured like might as well tie it in. Matrix, uh, predefines no. This, yeah. So it matrix, PTOS math. That's POTS math. Just gonna double check that I didn't misspell the whole file. Nope, that's good. transform vector, um, a modest amount of files have been modified. Uh, I could have kept it a bit smaller. Um, but like the main thing I was working on is the renderer, and the renderer needs the math code. And to test it, I needed a better, I mean, not really to test it, but like just in the way I wanted to test it. Um, I needed the delta time so I could move stuff around. Input kind of just happened because I was like, might as well. Um, and then obviously like shader because that's part of rendering, and then the component transform because that's part of um right because I want these scene items to like if they just directly stored the transform, then like how would you modify that? You know, you'd have to like do it yourself, and I kind of just felt like at that level I didn't want the do it yourself, but I kind of have no clue how interactive all this stuff is gonna be. Who knows? I might rewrite it later. That's kind of the worst case at this point. Um, yeah, like the worst case is I just like don't use this for the scene item and I just use it somewhere else down the line. But instead of actually storing the matrix it works on, it store more like a reference or a pointer to a matrix. I mean, it still already stores the pointer, but right now the pointer is actually assigned to the component transform. But and later it'd be more like the pointer's primarily assigned there. It's not like held anywhere else. But later it'd be like, hey, this here's from the scene item. You can work on this. You can like work with this and make modifications to this. And then that's what it would do. I could do it like that right now. I'm just not. Probably should. I don't feel like changing it. It's fine. Um, need an example. Add window and input. Item rendering. All of this kind of falls under rendering. So I probably keep that the same. Oh, notable files for. Okay. I'll have to split this up then. Math, how it fixes, um, feature, feature, um, Eh, I can do this later.
actually render our texture. So to render a texture, we need to render it on some kind of geometry. So we've got a vertex buffer here, which contains a square, which is fantastic. That's what we'll use. However, what I'll do is I'll hide this triangle. So this is us rendering the triangle. I'll just label it here so it's more clear. This is us rendering our grid. Literally all we need to do is take this submission, and instead of submitting, we'll change the transform around so that instead of it being tiny, I think what we're doing is we've got a position, which is fine. We can just leave it at the origin. However, the scale we did set to 0.1, which is kind of small, obviously. I think one is the size of that triangle, which was also a little bit small. So what I'll do is I'll just copy and paste this scale transform, but I'll change it so that instead of 0.1, it's 1.5. So it's a little bit bigger than just 1.0 scale. So we're scaling it up a little bit. We'll still keep the flat color shader and the square vertex array. So if we launch this right now, we are setting the color to blue here. So we should just get kind of like a large blue square kind of in the middle of our screen. And here we go. So there we go. We've got
Wow,
this blue square. Perfect. So
blue.
now what we want to do is instead of render the color blue, we want to sample each pixel from a texture so that we actually see our texture
I
on the
thought,
screen.
okay.
So to
Uh,
do that, the first thing you
I
need to
might
do
end a bit earlier than I was
is
thinking before.
change up this vertex buffer so that it
I thought
contains
I'd have more
texture
energy than
coordinates, because
this.
without texture coordinates we actually can't render anything, because we won't actually know which areas of the texture need to be sampled. So for the bottom left corner, this is the bottom left corner, we'll just use 0, 0. For the bottom right corner, it'll be 1, 0. So we're just going along the positive x-axis here. I'll just copy this quickly.
Yeah,
For
and
the top right corner,
this
this is
hasn't
going to be
had that weird error
1
yet.
for x and 1 for y. And then
Again,
finally, for the top
it's
left
weird.
corner, we're back to 0x
I don't
and
know
we're
what
still on
caused
1
whatever it
y. Now
did
this is
before.
expanded now. Instead of us having 3 floats per vertex, we have
Random red
5 because we have
line for
2
no
more for our
reason.
kind of
Or
2D
maybe
texture
there was a
coordinate here.
reason.
Floats per vertex, we have 5 because we have 2 more for our kind of 2D texture coordinate here. Let me just check that that's
2D
right.
texture.
And yep, that looks good. Okay, so basically, I mean, the way that you can follow this is if the negative 0.5 is negative, right? If the 0.5
Four is 1, 2, 3, 4.
is negative, then the texture coordinates should be 0. And if it's positive, then it should be positive. It should be positive 1, right? So 1 for positive, 0 for negative. And that way we can quickly check to make sure that everything is correct, and it is. So we need to expand this now. Obviously, we still have square vertices and the size of square vertices, so we don't have to touch anything here. For our layout, because of our beautiful layout system, all we need to do is just literally add
Ah,
another attribute here. There's going to be a float 2, and that's going to be called a text coord. All right. And that's it. I mean, if we just launch the program now, it should look exactly the same. And we have to just quickly verify that everything is correct. We should. So what I want to do now is create as before. All right, and now to be our text going to be copied. Now we're getting a library so that we don't have to define all this stuff inside our sandbox app. So that's definitely something that we'll talk about. This is going to be M texture shader. This is going to be, of course, our texture shader fragment source and our texture shader.
here. I do actually want to do this because if I make changes, um, if I make changes like with this, and then I'd have to like do this and then pull request, right? And then like it merges, and then I have to pull to my local dev branch. But then I already have changes. I could just stash them, yeah. Okay, it's not that big of a deal, but I kind of just want to do this right now. Um, math operator fixes. Yeah, it's not math fixes, it's math operator fixes. And then for that, it's transform matrix vector. This is gonna be actually math changes, uh, fixed operators made, I'll move things around. Right now it doesn't really make sense. So item rendering, and then not item rendering. Uh, added math. Added functionality thing for matrix operations. Meaning I probably want this one as well. Um, added functionality thing for matrix operations and fixed consistency issues with matrix and vector operator. Oh boy, what would I do without spell check? Um, example, I'm not, I could give an example. So what, it's just, um, you over here, and you say translate. It specifies, yeah. So do that, and we'll say, set player's position, and then we'll do PTOS. Um, um, right. Uh, um, Or, wait, oops. Pesos. Kilo math. Fine. Um, that with and without. Right. Yeah, sure. Um, the what third one, whatever, would be um I'm rendering. This one would be I'm not making a whole section for input. I could. Um, yeah, I'm gonna finish this and then stop. I'm tired. Uh, hold on. Is that? Yeah, I need this there. Um, what do I want to do? A wait for modifying uh, transforms by what's this one? Yeah. Um, it's really just this. Put it there. And I do this so that technically your headers are supposed to be like individual, so you can like jump between them. Because otherwise, if you have two identical headers and you try to jump to one, you could only like be able to jump to like the first one. I don't know how GitHub handles that. Um, right, and that's just what example. All right, and then we can say dt. Um, Let me check that. I'm pretty sure this. Yeah, it does a new there. Yeah. Um, and then it'd be like CT. Oh, hello. Yeah, I'm tired, and I want to write this pull request before I, um, stop. Yeah, I know. Really put in the hours. Um, I mean, it's not like I was really doing much anyway. Just like kind of following this tutorial for gaming and stuff. But yeah, have to document what I'm doing so that people know. Should be an F, an F, right? What does that look like? Oh, what the thing I'm coding does, right? I run it, it spits out a whole lot of warnings. Yeah, Whiplash. Yeah, it's good, okay? It's good music. Um, and then I get this, right? I can move the camera around, and then I can move the triangle around with the arrow keys. There's technically rotation, but it doesn't look too well right now. It's not supposed to do that. But yeah, we can just ignore that. And this is doing at like a good old 1,000 frames per second. You can tell because the log file is really great. Um, or whatever. And yeah, it's been really cool working on this. I got to write my own matrix multiplication code. Yeah, 400 errors, so many errors. Ideally, there'd be none, but it is what it is. Um, yeah, I want to move this part. What I'm writing for here, I mean, mainly the big thing I changed here was before. Yeah, I'm a pro scratch coder. You actually didn't do this right. But yeah, main thing I changed here is before you'd have to tell the shader like uh hey, draw this one thing. Um, and that's really lame. And now you can tell it, hey, draw this collection of things. I guess technically the renderer and that has like shaders. But yeah, the renderer now draws multiple things at once. Um, that looks fine. I really, I don't feel like splitting this up anymore. Um, that example's fine. My transform, that's fine. I just need to write an example for this. Yes, very Sigma. Oh, that's an emote you just used. I don't know if you have 7TV, but you just summoned this very Sigma wolf into the chat. Um, what was I doing? Examples. What are you doing right now? What are you doing? Example, example. We just mentioned to HD easy because $60 10 years ago. Yeah. We just mentioned too is the 3DS one, right? Um, yeah. I think yeah, it is. Okay, yeah. I have to I'm not in a thinking state right now. Um, yeah, I got to like the one with like I got to the part where it's like the ice and you have to shoot the ice face. And I don't know how many years it's been since I played that, but I just couldn't like balance it like my I couldn't because you have to do like the gyro shit, and I just couldn't do that, and it like kind of pissed me off, and then I stopped playing. um, clock man, was that there was like a sand one, right? If I feel like I remember there's like a sand one. Was that it, or is that like something else? Um, uh, yeah, that one was kind of crazy. That took me a bit. I think my favorite that I can remember was like the second one with like all the flowers and not flowers, but like plants. Like the second mansion, second one. And then you have a scene item. What you do item. Um, and then scene dot add item. Right, that's how that works. Pretty sure. Yeah, add scene item. That's a bit redundant, but sure. I don't feel like changing it now. And then that should be it for this. Right. I'm just gonna trust that Max actually like reads this. Um, and like catches stuff. Ooh, I could have you read this. You wanna review some code? You wanna you gonna have a go at it? Oh no. Like I could press the button, it'd probably send you an email, you know? It's only 500 editions, lines, you know? But yeah, I'm tired. I wonder if it'll totally freak out when cause my ending screen, hold on, I have to, yeah, okay. The villager video up here, um, that would play the sound over and over, and OBS decided that needed to be the maximum volume possible. Um, it was just a lovely little surprise, you know? Um, but yeah, I'm done. Tired. I'm beat. I'm pooped. Alright. You just fucking lol and what face? That's very good. That's very Twitch. Oh wait, hold on. Uh, I have a bot. You need to check out this bot. It's a cool bot. Does things. Okay. Um, like if you get the current song. Why are you using these emotes? Yeah, you baby rage, you little baby. You're a big baby. Alright, I'm done. I'm no more.